Let's try to solve this interesting analog VLSI question. In this question, it is given as input as step input and asked to find V out for two cases. R1 is equal to 0 ohms and R1 greater than 0 ohms. For clarity, first let's try to take what is Vn. Vn is step input, right? So it is going from 0 to VDD at t is equal to 0. This is what it meant, and our assumption is VDD is very greater than VT, the threshold voltage of MOSFET, okay, M1, and the current flowing through means the I1 current is 1 ampere for sake of easiness, and we can take this R1 as 1 ohm maybe, and this capacitor is also 1 farad, so that it will give result in some numbers, so we will get some good intuitive understanding at every instance. Okay, first let's try to solve this step by step. So what will happen to the circuit at t is less than 0 seconds? Okay, for t is less than 0 seconds, the input to the MOSFET will be 0. So circuit will look like something like this. Here VGS is equal to 0 volt. So the MOSFET equivalent will be open circuit. So if the MOSFET is open circuited, how you can redraw the circuit? You can simply redraw the circuit as 1 ampere is current is flowing here and 1 ohm, and this is your capacitance. This is 1 farad. So the complete current will flow in this path. 1 ampere will flow in this capacitor only. Since it is starting from somewhere infinity and it's keep on charging, right? So let's draw the graph with green. Okay, so the graph can be VC can be it is somewhere it will start and it is keep on charging. Okay, up to t is equal to 0. Up to this node it charges to some value. What is that VC value? If you want exact value, you can get it also. This is equal to 1 by C integral I dt. Here it is from minus infinity to 0. It will be 1 by C I t, limits goes from minus infinity to 0. It will be kind of infinite. VC is equal to infinite. So let see some voltage. Okay, some VC is equal to some very high voltage that can be considered. So what about the second graph we can draw here is about current flowing through. Maybe this current flowing will be IM, okay, MOSFET current, and this will be IC, capacitor current. What is the IC here? IC will be constant 1 ampere, and IM is equal to, it is 0 constant. Okay, that's the information we have for t less than 0 seconds. Let's try to solve for t greater than 0 seconds. For t greater than 0 seconds, the input will become VDD, right? So VGS is equal to VDD. So this can be approximated as a resistor. The behavior of MOSFET will be resistor in triode region, right? Deep triode region, as we know. So the circuit can be redrawn as something like this. We can redraw the circuit. Okay, this is 1 ampere. This is your R. This is R on. This is C. Okay. Now here it is given as R1 is equal to, first case, okay, R1 is equal to 0 ohms. If R1 is equal to 0 ohms, means what it literally means is it's short circuit. So the circuit can again be rewritten as, let's change the color to blue, and the circuit can be rewritten like this is short circuited, right? So the complete current will flow through this MOSFET only. So now let's draw the graphs. All 3 graphs we will try to draw, then it will be clear so far. So the IC is like this. Now suddenly here one thing is VC is equal to V out. Okay, you see in the circuit the voltage across here VC will be same as V out, since both are in parallel. Okay, both will be same. Okay, so this VC or V out will be kind of going up to here. Now it suddenly, since it is short circuited, it suddenly go to 0. We need to know the reasoning of why it is going to 0. Here if you see, at this instant at t is greater than 0, we have capacitor with very huge voltage. That complete huge voltage is parallel with a short circuit, so it will instantaneously discharge all its voltage. Okay, completely discharged, so the current will be infinite. If you draw the current graph now, this IC graph, until that point it is 1 ampere, continuously 1 ampere is flowing, but at this instance there is an infinite current means impulsive current will be flowing in opposite direction, in this direction. This is IC direction, right? In opposite direction there will be infinite amount of current that will make the V out from a certain value to 0. This is the graph of IC. Now if you see IM graph, MOSFET current graph will be kind of, it is 0 initially up to 0, so it will now enter current is flowing through this, so it will be kind of 1 ampere flowing after t is equal to 0. Okay, this is how this circuit will work for Rm is equal to 0 ohm. Let's see what will happen for second case is R1 is equal greater than 0 ohms. If R1 is equal to 0 ohms, the circuit will be kind of like this, as we tried earlier. This is kind of interesting analysis, we should very thorough with. Okay, here the R1 is greater than 0 ohms. The graphs earlier, like this VC graph is kind of like this. It reached to some point, very huge maybe, and this IC graph is constantly 1 ampere only, and this IM graph is constantly 0 until the point of time t is equal to 0. Okay, now what will happen after time t is equal to 0? So if you see here, now 1 ampere current cannot flow through both of them because there is some X voltage here. Now that X voltage should definitely be reflected as V out, means at R1. Okay, that same X voltage is there, so the current flowing through here should be that X voltage divided by R1. So where that current will come from? Definitely this X by R1 can't be given by this 1 ampere means this 1 ampere current source. So that current will come from this capacitor. Okay, this capacitor will contribute some amount of current, and this current source will contribute some amount of current. If this current is passing from capacitor, means it literally means it's discharging, so the voltage in this capacitor will start to discharge. Okay, this voltage will decrease. Now what will happen here? Okay, at steady state, what will happen at steady state? If you see, you will get some kind of clarity at steady state. At steady state, the capacitor, we know that capacitor will act as open circuit. Okay, means it will not further charge or discharge. That is the steady state for capacitor, right? So the 1 ampere current will completely flow in this R1 only. So the voltage drop here, it will be that VC will be VC is equal to R1 into this I, which is 1 ampere. So it will be R1. So the VC voltage will discharge until it reaches to voltage of R1. Okay, this, if you see this graph, IC graph now, the IC it start the 1 ampere at this point it started to discharge more, means in negative direction it went, and it reached to 0, means the current flowing through it is 0. Okay, the graph of IC will look something like this. Finally there is no current flowing through IC. If you see IM graph, right, the IM will be kind of first very huge amount of current